dimensional analysis, we're going to be doing this as a special type of conversions. Okay? So the first set we're going to be working on is looking at metric conversions. And then we'll be talking some metric to English conversions. But this is a special method that we use here in chemistry. You'll use it in physics later as well on how to convert. And it's called dimensional analysis. It's a method that you have to use in chemistry. It's part of our SOLs and part of our standards. So you can't just do regular conversions that you've done before in the past. And hopefully you will eventually, by the time you master it, agree that it's a very easy method and a good method for setting these up. So on the front here, I put the chart for you, okay, and the mnemonic. Best way to remember your metric prefixes. King Henry died by, this is the base unit, drinking chocolate milk, okay? And you probably are most familiar with the kilo, the centi, and the milli. Those are the ones we use most of the time in the lab, okay? We'll be going with using the mnemonic to decide on the conversion factor. This is a 10-base system, so it's easy to go between them. Everything's based off of 10. So there are 10 decigrams in 1 gram. The next one over, add a 0, 100 in the 1, and so forth. And we work off the base unit. And actually, we could go from like hecto all the way to centi without having to look at anything else, just based off of the base 10 rules. Down here, I put some other ones in the chart for you. Okay. These ones are extra. Some of them you've heard of, like giga, mega. Probably, sorry, not Billy, but micro you've heard of from biology, because micro is, like cell size under the microscope. Nano, that's more for like wavelengths, like visible color spectrum and all that. We're going to get into pico more for just like atomic size, but we're not really going to be, calculating a lot with it. That's more of like an AP to be doing with that. But down here, if you forget the steps at all, the steps are written here for you. Draw the fence or the track. Write what you've been given in the upper left corner, the number and the unit. Take the unit that's upstairs and bring it downstairs. I call it the diagonal down. And pick the unit for upstairs. That's usually the one that you're going to or the one that you want. Insert your conversion factor. Cross off the units, just like we did with the density units. Multiply the top and divide by the bottom. And then put your correct number in. The correct number is Sig Figs. So your calculator answer goes to Sig Figs. Everything's in Sig Figs from now on. So all that's a lot of steps, but here we're going to go start working through them. Looking at number 1, when I say you put the given information in the upper left corner, how many liters are in 2,500 milliliters? The given information is the 2,500 milliliters. So that's where we're going to put that in the upper left corner. Okay? That whole thing goes in the upper left corner. Now, when we say take the unit that's upstairs and put it downstairs, that's the diagonal down part. You're going to take this milliliter and you're going to put it down here. You're not going to move the number though. You're only going to move the unit. Okay? The unit that we want, which happens to be what? Liters. That's the one we're going to put up top, right here. Okay? So this is the basic setup. Now we have to figure out our conversion factor. And since it's metric to metric, we need to do our King Henry died by drinking chocolate milk. So you can list it down the side of your paper like that, like I do. And if you remember the mnemonic, you should be able to go from kilo all the way down to milli. So we're working here with the liter. Remember, the base unit is liter, meter, or gram here. Those are all considered base units. There are other ones like joules. Joules is for energy, pascals is for pressure. There will be other ones we'll eventually use. Calories you can use as a base unit. You can use seconds as a base unit. You can use lots of different things as a base unit and apply the metric prefixes. Okay? So if we're looking here, remember on the front, the kilo, these are the larger prefixes. Down here are the smaller prefixes. So when figuring out the conversion factor, you always want to look at which one's the larger one out of the two. Is liters a larger unit than milliliters? Yes. So since liters is larger, I'm going to give it the 1. Now, it's going to take me 1, 2, 3 hops down to get to milli. Right? Everybody see that? So each hop is like multiplying by 10. So this is going to be a 1 with 3 zeros. 3 hops, 3 zeros. I multiply it by 10 3 times. That's basically what I did. Okay? So this is 10, 100, 1,000. Right? Now all I have to do, so if I know 1 liter equals 1,000 milliliters, I just have to insert it into my track. The 1 goes with the liter, the 1,000 goes next to the milliliter, and I have my setup. Then, as the steps on the front say, you need to multiply the top and divide by the bottom. Just like that. Multiply the top and divide by the bottom. And we end up with, what is our answer? 2.5 liters. The milliliters cancels with the milliliters. Remember, if it's above itself like that, they just cancel out. Okay? And we're going to end up with 2.5. Yes?
But we're doing a proportion, sort of, like, multiply the...
Well, not really a proportion because there's not equal sign between them. You really are just taking everything on the top, multiplying it, and the tracks will get longer, so we're going to insert more conversion factors. I call these the one-steppers. So they take 1 conversion factor. We're going to have 2 steps, 3-step ones that get really long. And so you multiply everything on the top, multiply everything on the bottom, and then you just divide it out at the end. So it really just becomes like a series of fractions, you know, multiplying the fractions along. Okay? Now, in terms of Sig Figs, the metric to metric ones, the numbers really don't change because all we have there, we're either adding or subtracting zeros to it because it's all a base 10 system. So here, if you look at our original one, how many Sig Figs do we start with? Because it's 2,500, you start from the right, no decimal point, you're only going to have 2 digits there. So in the end, 2.5, guess what, only has 2 digits for the same Sig Fig rule there. Okay? But we're going to get down here to number 3 and 4 where we're going to be using metric to English. So the significant digit rounding is going to be a little different there. Well, let's try number 2. What is our given information there? What do we need to put in the upper left corner? 62 meters. Good. What's my next step then? I'm going to do my diagonal down first. I'm going to put that one down because I want to make sure I get it in the spot first. So I'm going to put my meters down here. Then I'm going to look at what do I want. I want the decimeters, so I'm going to put that one up here on the top. Right? Now, coming over here to my King Henry. Okay? I don't need milli, and I'm looking at meters this time. So I'm going to look over here at my meter base unit. I have meters and I have deca. This one's the deca. Deca's above the base unit. So who's larger, meter or decimeter? Remember, these are the larger all the way up here. So meter is at the base unit. Deci's just one below it. So meter gets the 1. How many hops down? So that's just times 10. Just 1 0. a 1 and 1 meter is going to equal 10 decimeters, right? So I'm going to insert the 1 this time next to the meter, and the 10 is going to go on top. The 10 belongs next to the decimeter, the 1 belongs next to the meter. So 1s aren't always going to be on the top, they're not always going to be on the bottom, they're going to go with the unit they are with. Now what we're going to do is we're going to multiply the top and divide by the bottom, and we end up getting 620 decimeters. If you set it up right, the one on the diagonal should cancel. Meters cancels with meters, like so. If it was set up correctly, you should be able to cancel those units and then be left with the unit that you want. That's the one we want, and it's left over. So, good. Now let's look at a metric to English one. Actually, this is an English to metric one, because we're going from pounds to grams. Now, on the English to metric conversions, guess what? In a sense, they're kind of easier, because the English units they don't have a base 10, they don't have a system to them. They're all pretty random. So what do we always have to do for those? We give you the conversion factor to the rate. Or we'll give you a table of conversion factors for English to metric, so you don't have to, come up with them yourself. The only ones you're going to have to come up with yourself are from the metric to metric. Be able to go between the prefixes. Okay? So, 3 pounds. And 1 pound here, the abbreviation for pound is LB, so I'm going to put 3 pounds up here. My upper left corner, I'm going to create my track. Next step is to do what? Diagonal down. Pounds go down here. What am I trying to go towards? What am I looking for? Grams. So grams is going to go up top. Now, do I have to do the King Henry? No, because it's not metric to metric. All I need to do is look over here. 1 pound equals 453.6 grams. So I'm going to put the 1 next to the pound, and I'm going to put the 453.6 next to the grams. Now I'm going to multiply the top, divide by the bottom, and I'm going to get a calculator answer. 1360.8, right? Now, this is where it gets tricky with the English to metric. You have to round your answer to the number of Sig Figs in your original measurement. How many Sig Figs did our original measurement have here? 3 pounds is 1 digit. So how many digits do we get to have at the end here? 1 significant digit. So we start with our 1. That's our one we get to keep. Do we round it up to a 2 or leave it a 1?
Leave it a 1.
So it's going to say a 1. And then everything else, those other 3 place values become those filler zeros. Don't forget to put your gram on the end so that you have your unit. We don't want any naked numbers. Numbers need to have their units. All right? So what I'd like you to do is I'd like you to try number 4, see if you can set it up. And then we will come back and I will work it out for you. So if I'm setting this one up, I'm going to put, oh, still frozen, hold on. So in setting this one up, I'm going to put my given information in the upper left corner, which happens to be, what? 5.3 feet, good. That goes in the upper left corner. Then I'm going to diagonal down the feet. Good. You go down here. What am I trying to go to? Meters. Meters goes up top. Good. Now I come over here. Look at my conversion factor. 1 foot was 0.305. So the 1 goes next to the foot. 0.305 goes next to the meter. I multiply the top. Divide by the bottom. And I'm going to get my calculator answer. My calculator answer happens to be 1.6165. How many digits do I get to keep, though? How many are in this beginning measurement? Only 2. So I keep the 1. Do I round the 6 up or leave it a 6?
Leave it a 6.
Leave it a 6. My final answer, Sig Fig answer is 1.6 meters. Don't forget your unit, because the feet cancel, like so. So meters is what's left. That's what we want.
Why don't we leave it at 6 again? I forgot.
Sorry?
Why do we leave it at 6 again? I forgot.
Because to the right of the 6 is a 1,
Oh,
and it would only be rounded up to 7 if that number to the right of the 6 was a 5 or above.
okay.
So good question. Good question. All right, let's look at a few more, and then I'm going to show you a two-stepper. All right, here. How many centimeters are in 0.13 kilometers? This one goes back to the King Henry idea. So we have our 0.13 kilometers, and we're going to go to centimeters. Diagonal down those kilometers. Put the centimeters up top. That's what we want. But now we have our King Henry died by drinking chocolate milk. So we have kilo all the way up here, and we have centi down here. Who's larger, kilo or centi? Kilo gets the 1. Now we're going to go 1, 2, 3, 4, 5. So this is a 1 with 5 zeros. We're multiplying the 5 times. 10 times 10 times 10 times 10 times 10. 5 times. Multiplying that 10. 10. So, 1 kilometer equals 100,000 centimeters. Everybody see that? So, now we can cancel the kilometers and end up with centimeters. This ends up being what? 13,000, right? Now, the Sig Figs work out nicely here because this one only has 2 to begin with, and then these 3 zeros over here are not significant because they don't have a decimal by them anyways. That's why I said the metric in terms of significant digits are a lot easier because you're really just moving the zeros around. So that would be the final answer there. Now, for number 6, let's revisit Miss Sacramondo's about 5.3 feet tall. Okay, and let's think how she's going to be in centimeters. So we can do this one of 2 ways. First way, I'm going to set it up because we're going to go to centimeters now. I'm going to set it up as a 2-step problem. So, still put my 5.3 feet up here, upper left corner. And I'm going to follow what I did in number 4. I'm going to change my feet to meters. Okay? I'm going to do what we did up there in number 4. So 1 foot equals a 0.305 meters. But I don't want meters. I'm going to continue on and keep converting it till I get to centimeters. So I'm going to add another track. See? I'm going to add another one on. Now, the feet are going to cancel with the feet. So, what am I going to diagonal down now? Meters are going to go down here. The meters are going to be diagonal down. And then I'm going to be able to put what on top? What do we want? Centimeters are going to be able to go up here. So, see how the track can get bigger? Okay? Now, for King Henry, base unit, that's meter. Centa, 2 down from the base unit. So 1 meter is going to equal how many centimeters?
2.
A 1 with 2 zeros, so it'd be 100. So it's like 10 times 10. What's 10 times 10? 100. So 100 centimeters equals 1 meter. And now my meters will cancel with my meters, and I'm left with centimeters. This is a 2-step. Setting it up, you can keep going. You can continue to convert. Now, all you have to do here when you have a bigger track is multiply everything on the top first, multiply everything on the bottom, and then divide at the very end. Although they're both 1s on the bottom, so that's an easy division. So, we would multiply everything on the top, multiply everything on the bottom, and then divide it out. So, I end up being 161.65. Now for our correct number of significant digits, we have 2 again to start with. So I'm going to keep this one, keep the 6. Do I round up to 6 or leave it alone? So now it's 1/6. What do I must do with my 1's place value? Turn it into a filler 0. So I only have 2 digits, 2 that are significant. Don't forget my unit, centimeters. One last little example before I let you get started on what you need to finish for our next class. We have 13,458 feet. A lot of feet. What do I do with my feet? Diagonal it down here. I'm going to put my miles up here. And we make miles MI instead of M because M is meter. Most people believe M is meter, so we're going to put MI for mile. So 1 mile equals 5,280 feet. Set up your conversion factor. Feet cancels with feet. Multiply by 1, divide by 5,280. Get your get your calculator answer so we can do significant digit answer. So this ends up being 2.5488 something, right? 886. Well, we have a lot of digits over here. How many are in this number? 5 digits. How many do I need to keep then? 1, 2, 3, 4, 5. Do I round that up or leave it an 8? This one's going to get rounded up, so it's 2.5489. Don't forget your unit. Miles.